On number 7, again, we're looking to see if this is Bernoulli. And you can write this as a Bernoulli ODE by breaking the right side of the equation up into y squared over x squared plus 2xy over x squared. On the second fraction, one of these x's will cancel, so that you get 2y over x. And if you bring that term over to the left side of the equation, you'll have dy dx minus 2 over x times y is equal to, and on the right side I'm going to write this as 1 over x squared times y squared. So notice I have my derivative term minus my function of x times y is equal to another function of x times y to some power. So this is Bernoullian form, and the value for n again is 2, and so we're going to let u equal y to the 1 minus second power, or y to the negative first power. That gives us y is u to the negative first, and y prime is negative u to the negative second du dx. And so we'll make that same substitution we did as in problem number 6. Here we get negative u to the negative second du dx minus 2 over x. In place of y, we're going to put u to the negative first. U to the negative first equals 1 over x squared, and for y again we have u to the negative first squared. We want to write this in linear form, and to write this in linear form we want to get rid of that negative u to the negative second. We can do that by multiplying by negative u to the second, so that our first term just becomes du dx. Here we're going to get a plus 2 over x times u. On the right side we get 1 over x squared. This u to the negative second and u to the second cancel, and I'll have a negative from that negative in front of the u squared. Okay. Notice that this is linear. You have your function, derivative, plus a function of x times u equals another function of x. And so we're going to introduce an integrating factor of the form e raised to the integral of 2 over x dx. That's going to give us e raised to the 2 natural log of x, or e raised to the natural log of x squared, and that e and natural log cancel to give me just x squared as my integrating factor. And so I want to multiply through by x squared, whoops, to give me x squared du dx plus 2x u equals negative 1. Notice that the left side of the equation can be written as the derivative of x squared u and then from here we can integrate both sides of the equation with respect to x. So that, let me bring this up here, so that we get x squared u is equal to negative x plus c. That x squared u comes from inside the brackets, and when you integrate negative 1 with respect to x, you get negative x plus the constant of integration. And here I'm going to divide by x squared. So I get u is negative x plus c divided by x squared. Well, u is the same as y to the negative first. So I get y to the negative first equals negative x plus c over x squared. And then taking the reciprocal of both sides will give you a y on the left side, and on the right side just flip that fraction to get x squared over negative x plus c.